In an isosceles triangle, hold on, I'm going to yell at my kids. In an isosceles triangle, we know that two sides are the same. What else do we know? And you could please put this in the chat. Two sides are the same. What else? That is true in this case. But I'm kind of looking for a similar answer for two sides are the same. In the isosceles triangle, two sides are the same, and two angles are the same. So Santi said that this guy is 3x plus 6, but also that guy is 3x plus 6. Now, would I get anywhere? If my job is to find x, would I get anywhere if I said 3x plus 6 equals 3x plus 6? No, I wouldn't. But what I do know is that I know that h is 90. And all three of these angles add up to what? All three of the angles add up to what? 180. 180. So I'm going to say 3x, that's a 3, as you can clearly see, plus 6 plus 3x plus 6 plus 90 equals 180. Sloppy. I'll give you a 30-second head start, and then please put your answer in the chat. Okay, we have one answer already. I actually don't know what the answer is, so we'll see. So I'm not going to be like, yes, you got it, because I don't know. All right, on the left side, I have, so Santi is backing up Athena's guess. 3x and 3x makes 6x. Ugh. The green does not show up on this blue. 6x plus 6, 12. What would that be? 102. Minus, if you hear beeping in the background, that's my baby monitor. That's batteries are dying. I screwed up and I chose green again. Green does not work, dunderhead. Minus 102. After we minus 102, what will be my next step? I just want you guys to throw the answer in ahead of time. After I do that, what's my next step? Divide by 6, says one of my friends. 78. And yeah, I think you guys are right. X is going to equal 13. Superstars at solving equations. All my friends are superstars, solving equation masters. It's a song I just wrote about you guys. I call it Solving Equations Masters, because you're masters at solving equations. Now, that's the type of problem that, you know, don't be too surprised if you saw something like that. From here on out is a challenge. To be fashionable, you got to be coordinate. I don't get it. I don't get it at all. But okay, I mean, we are talking about coordinate proofs today, so I don't know. What is a coordinate proof, you ax? A coordinate proof is a proof that uses made-up coordinates to show that maybe two triangles are the same, or two segments are the same, or two angles are the same. That's what a coordinate proof is. We make fake coordinates based on arbitrary lengths. So right now you're saying fake coordinates, arbitrary lengths, sign me up. But you know, it is a challenge. Oh, pardon me. One of my daughters is disrupting my class. Yes. You're full of baloney.
How dare you?
How dare you? Get out of here, you little sprat. I love you. You're beautiful.
Well, I got spanked your butt.
Do you hear what she said? She said she's going to spank my butt. Good. All right. I love you. If you're full, then you can be done. Keep the door open, though, so I can make sure you guys aren't burning the house down. Keep the door open.
It's already over.
All right. Thank you. Love you. Bye.
Bye.
Mwah. Keep the door open.
I like poopy.
I know you like poopy. Very good. My 5-year-old daughter. What a sweetie. All right. When we make ourselves a coordinate proof or a picture based off of arbitrary coordinates, these are the 4 steps that we're going to try to use. The center, or where we begin things, we're always going to label 0, 0. That's the origin. Okay? We're always going to label 0, 0. If we make up a length, we're going to try to put that length on one of the axes, usually the x-axis. That's step 2. Step 3 is, and this is talking specifically about triangles, but these rules really apply for any shape that we do. Keep the triangle within the first quadrant if at all possible. There might be times where, there is really no reason why you can't keep your triangle in the first coordinate unless you're drawing several triangles. So I will always try to do that and use coordinates that make computations as simple as possible. Like, I'm not going to be like, let's make believe that the length of this thing is 14/15 inches long. Like, why would you do that? You would call it A. So, there will be times, and it probably won't be until about pre-calculus where you may not do this, but there will be times where you're going to make proofs and you're going to make fake coordinates. You see letters like this when I don't know if you did the quadratic property last year, the quadratic formula last year. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Ring a bell. And of course, as usual, no one's responding fast enough for me to be satisfied. Maybe you didn't. I don't know. Maybe that was towards the end of the year where you weren't able to get to it because of pandemic. But you'll see it soon enough. If this is just an example of what we're talking about here. Name the missing coordinates of an isosceles triangle XYZ. This is just a fake triangle. All right, and I'm not going to look at this. Here, watch. This doesn't exist. Of course, what am I dealing with here? Find the missing coordinates of an isosceles triangle XYZ. All right, so this is an isosceles triangle, and I am assuming, and I'm allowed to assume because I'm picking out the coordinates here. I'm assuming that these guys are the coordinates sides, or the congruent sides. In the chat, take a wild guess what you think the point for X is. It is super obvious. Like, if I were to put a dot right there and say, what dot is that? What would you call X? 0, 0 is correct. 0, 0 is correct. I always say he looks like a guy with his eyeballs and a nose. And then I have, let's do Z next. An owl. That's outrageous. Z is probably easy to do the next one. Z is A and then a number. Now, what that is saying, and follow me, this is where it starts to get really complicated because finding X wasn't hard. I mean, if I wanted to find an X, I'd just look on Facebook, right, guys? Ex-girlfriend. But anyway, yeah, that was easy. If I wanted to explain what Z means by saying that this is A By saying that this is A something is telling you that the length of that line is A units long. So if this was 5, then that length would be 5 because it goes from 0 to 5. This is going from 0 to A. So Z is the point A, which represents some number. A what? What's the second coordinate? A 0. Why? Well, do you see how it's attached to the x-axis still? Like if that was a point, like if I said that this was 4, it wouldn't be hard for you to say, well, then that's 4, 0, because it lives on the x-axis. You go right 1, 2, 3, 4. 4 is 0. You don't go up or down. Great. This is where it gets a little complicated. Now, I don't know what this line is, so I'm going to call it B. So Y is going to be something B. There goes my dog. Something B. Since this is an isosceles triangle, keep the door open. Here, right here. She might be awake. She's just she's not making noise, but okay. Praise the Lord. Good to hear. X would not be 0. Great question. No, it's the point up here. So what we have to understand, if these two sides are congruent, that's literally the halfway point of this line. So this dot is A over 2. Now let me explain myself again. Okay, let me explain myself again. Let's see if I get it right. Vertex X is the position. Okay, so vertex X is the origin 0, 0. Vertex Z, so I did go in the order that they did too. Vertex Z is on the x-axis, so the y-coordinate is 0. The coordinates of vertex Z are A0. XYZ is isosceles, so using the vertical segment from Y to the x-axis, it's halfway. So this is A, which means this halfway point is A divided by 2. And do they use A over 2? They use A over 2. I don't know what height that is, so we're calling it B. So if there's no absolute way that we can call something something, then we have to give it a brand new letter. So obviously we'll call the height B. It might be tempting to say, well, it looks like it could be the same length as A. It could be, but I don't know. I just know that that is some random length tall, so I'll call it B. The y-axis is how tall it is, and the x-axis is how wide it is. So let's, those of you who actually are taking notes, let's write that out. X is how wide the shape is. So you follow along the x-axis, and y is how tall something is. So when I'm going along the y-axis, if I go from 0 to that number that I don't know what it is, the y-axis tells me that it's B units tall. The x-axis here is telling me that it's A units wide. So in the world of teaching, Miss Harris, what I do is I'm surveying the class to see if everybody understands. And by the look of their profile pictures, I have no clue. So, you know, it is a very challenging topic. And again, you know, you won't see this on a test, but you'll see its concepts later in life in higher level math classes. And you might say to yourself, well, I'm not going to take higher level math classes. I'm going to be an engineer. I literally just in the last week and a half interviewed 5 people, and you saw that video probably. I interviewed 5 people. 2 of them are biomedical people. One of them is a computer design person. Biomedical, computer designer. One went for psychology, so no, they didn't do a whole lot of math. what was the other one? What was the other one? What was the other one? Journalism. So they did do a whole lot of math. But of the 5 people that I spoke to, 3 of them had to take calculus 1, 2, 3, and advanced. And as Miss Harris knows, those aren't baby classes. And I'm teaching calculus right now, and a lot of those kids are drowning. And you guys will take calculus in 11th grade. And not that you're going to use these, but we will use concepts like this when we talk about like the derivative of a blah, blah, blah. The derivative of ax to the nth is going to look like nax to the n minus 1. And if you're like, huh? You'll get there, but you use arbitrary letters to help you figure out formulas. And right now we're creating the formulas, so to speak. So not the most fun thing in the world, but I honestly enjoy it. Let's see. I'm not finna cap. I'm not going to cap. This one's actually pretty easy. This is an isosceles right triangle. So I can, if it's an isosceles right triangle, I know 2 facts about it. And we're not talking about A's or B's or anything like that. It's an isosceles right triangle. So what do I know about this triangle that I can maybe draw on the triangle to help me see it better, to help me visualize what I'm doing? The 90-degree angle. So, and Santiago said that the B is going to be that 90-degree angle. So that's perfect. That's one of them. So B, Santiago, you're jumping the gun. But yeah, you are correct. But we're not going to say that quite yet. What else do I know about this triangle? If we got the right part down. What else do we know about this triangle if it's an isosceles triangle? 2 equal sides is correct. Now, is it going to be AB? Is it going to be BC, or is it going to be AC? Which 2 sides are going to be the equal sides according to the picture that I have here? And there's only one way that I can write this out to have it make sense. BA and BC are the equal sides. Good. Okay. So I have A. And just because I write it out in alphabetical order does not mean that when we're going to answer these, when we answer these, we're going to answer in alphabetical order. In fact, we're not going to. Santi already gave us the one answer. And when my YouTube finally blows up, all the millions of viewers at home don't see Santi's answer. But Santi is right. Let the record reflect that Santi is correct. Santi said that first B is 0, 0. Why? Because it's at the origin. What's the next point I can find, and what point would that be? I have A and C left. C, which means yes in Spanish. C. CC, carbon copy, email. All right, so what is C? I know it's A. A what? So Santi is correct. A and C would have 0, so 0 there. Good. So C is done. And Athena is saying that, did I get this backwards? That A was, or did she do C? Hold on. Let me go back to the chat because I lost it. Okay, Athena is saying that, yeah, she said the answer like right as I wrote it down. Okay, good. So we have C, and we have C is A0, and she is correct, and you guys are correct. Santi also said that A has a 0 in it. Is the 0 for my A the X coordinate or the Y coordinate? The X coordinate. So I'll put a 0 right there. Now, in the last problem, so what this is saying is this length right there is A units long. In the last problem, we called this B because we didn't know how tall it was. So what do we know? What do we know? Do we know how tall it is, or are we just going to call it B? Do you know how tall it is? How tall it is? How tall it is? Do you know how tall it is? The answer is yes. Because, see, these little lines means the sides are the same. So if that is A units long, How tall is that? A units long again. So we can call it A. What's that? Somebody said, well, what if we just call it B? Well, if we call it B, then it may not help us when we try to prove things, which is what we're going to do next. And we're going to do that in the form of a little something called coordinate proof. BARF. BARF City. The reason why I'm not going to force coordinate proofs on this class is because they look like that. And if you say, if you're currently saying to myself, my goodness, Mr. Perich, that's an awful, terrible mess. You're 1,000% absolutely right. It is a terrible, awful, terrible, awful mess. It is such an awful mess, and it makes me angry just looking at it. But what we're trying to do in this particular problem, and I'm trying to read, the last time I did a proof that looked like this, like I did these when I was in grad school getting my master's degree. So this is the type of high level thinking we're dealing with here. You know, and you'll probably do proofs like this if you take higher level math classes in your bachelor's degree. So it's pretty messy. It's pretty messy, but they named these points. Maybe they named them. I don't know. Maybe I have to, when we do a proof on the next one, maybe I have to name them. They didn't use a 2-column proof. They used a paragraph proof, and that's what I'm going to use as well. They use slope formula to find out that this slope and that slope are both 0 and therefore are parallel. So time to ruin some mornings or afternoons. How much time do I have? 14 minutes. I'm gonna get a piece of blank paper because we're gonna need all of it. I'm gonna move to my document camera. So you're gonna want to pin. I'm gonna keep presenting this, but you're gonna want to pin my screen, my face screen. That's gonna be my document camera screen, and I don't even have it plugged in. Well, that's dumb by me. What a dumb move by Mr. Perich. Ugh. All right. That's got to plug in and boot up. In the meantime, here's a picture of a chicken that my daughter drew. Yeah, it's not bad. This is not the daughter who likes murdering chickens, but I think it's adorable because look at the big chicken and there's the baby chicken who is now being cradled in the arms of the Lord. Golly, kids are something. All right, you're gonna want to pin my screen and so you could see everything that I'm doing. Again, full disclosure, very, very, very difficult stuff. Stuff that I'm not going to force on you at the 8th grade level because I think it's bonkers. Still, if you're looking at this and you're like, I think I understand some of it, I kind of get it, then boy, are you in great shape. I mean, in my honest opinion, if I were to walk into my calculus class and did this and half the class got it on the first try, I would be so happy. So, you know, that's where we are with this type of problem. All right, so let me draw the picture again. I should have printed it out. It's too late. Oh. we have that. This is F0 B over 2. This is G A B gab. Oh, you guys do that all the time. This is H A 0. This is C, which is negative A 0, and this is D, which is negative A B. I have to prove that the two triangles are the same. And the way that I'm going to prove that the two triangles are the same is I'm going to use SSS. I am going to show that this side is the same as that side. I'm going to show that this side is the same as that side. And I'm going to show that this side is the same as that side. And here's how I'm going to do it. How tall is C? And you can put it in the chat. How tall is C? Or CD, I'm sorry. How tall is that side right there? Very close. This part is B over 2, so the whole side is going to be what? Just B. So this side is B because it goes from 0 to B. How tall is this side? The same as that one. So DC and GH are both B, so DC is congruent to GH. This is where it gets iffy. This is where it gets iffy. I need to show that this length is the same as that length, and the only way to show that those two lengths are the same is the distance formula. So I'll call that CF, and I'm going to use the distance formula. And let me remind you what the distance formula is. It's it's the big square root of x sub 1 minus x sub 2, all of that squared, plus y sub 1 minus y sub 2, all of that squared. So if I called you x sub 1, y sub 1, and I called you x sub 2, y sub 2, oh boy, I just feel so much anxiety doing this problem already. I have negative a minus 0, not bad, squared, plus 0 minus b sub 2, or b over 2 squared. Negative a minus 0 is negative a squared, plus 0 minus b over 2 is b over 2 squared. Negative a times negative a is a squared. And b over 2 times b over 2 is b squared over 4.
Fun. Now we have to do FH. So that's done. I'll call you x sub 1, y sub 1. FH is the same thing as a big square root a minus 0 squared plus 0 minus b over 2 squared. A minus 0 is a plus b over 2 squared, negative b over 2 squared, and I guess that should have been negative b over 2 squared. It's not going to be a difference. And that also gives me a squared plus b squared over 4. They're the same! So, CF is congruent to FH. So now I have proven that those two sides are the same, those two sides are the same. Now I have to prove that the purple sides are the same too. Which, oh man, I don't know if I have time to do that. So I'm just going to warp speed do this. Operation warp speed, but without vaccines and instead numbers. All right, so I have to prove that DF is congruent to GF. Hey, you, I don't like your GF, girlfriend. DF is going to be negative a minus 0 squared plus b minus b over 2 squared. Oh my gosh. So I don't even know if you guys learned how to FOIL last year. That involves foiling. This is a nightmare. Negative a, oh no. Okay, I'll take that as a no. Plus b minus b over 2 squared. And I'm just going to make that easy. A squared plus b minus b over 2 squared. I'm going to leave it like that. Maybe they did learn FOIL. I don't know. I don't know if you did or didn't, but I can't do it right now. This guy is the exact same thing, but a minus 0 squared plus b minus b over 2 squared, which is the same thing as a squared plus b minus b over 2 squared, which is the same thing as a squared plus b minus b over 2 squared. Those are the same. So DF is congruent to GF. And now I can say that angle FGH is congruent to triangle FDC because of SSS. So, listen. I ain't got cap. Except I'm going to put the cap on this here pen. Well, I know I said no cap, but I just capped the pen.